What's up, baby? All right, so welcome back. This is part two. Imagine you're in an interview and you don't even know what the people are talking about. Well, you won't know if you don't pay attention. I remember at a certain point where I didn't even know what they were talking about. And slowly, you get into a better space. And that better space is being cognizant of what's going on around you. So let's work on your vocabulary. All right. The next word we're going to work on is algorithm. So, an algorithm is a set of well defined step by step instructions or rules for solving a problem or performing a task. That's what an algorithm is. It's literally, if you look at a set of directions, step one, step two, step three, that's what an algorithm is. Step by step, solving a task. What we do in computing is we go step one, step two, step three. If step three doesn't work, go back to step one and then go step one, step two, step three. If step three does work, go step four, step five, step six. That's literally all it is. A real world example is the algorithm that a GPS app uses to calculate the fastest distance from your current location to your destination. It literally does exactly what I said. It goes step one, step two, step three. If there's a blockage here in step three, go back to step one, step two, step three. If I can pass step three, I'll go past step three. I'll go to four, five, six, seven, all the way until I get this person to the destination. So turn right, turn left, go forward, go straight, slow down, speed up, red light camera coming up. All of these things happen throughout the system, and it consistently calculates it if it's something as like high tech as a GPS system that gets you to your destination. That's why it can give you a lot of different routes. It can change the routes because in the background is consistently computing. All it is a step by step process to solve a problem. It's not this big crazy word that the culture has allowed for it to take. All right, so the next one is agile. Remember, last time I said something different about agile and the video was wrong. Go check it out on part one. We got a blooper. But agile, this is for my project management people. What agile is a flexible, collaborative approach to project management and software development that emphasizes customer collaboration and rapid response to change. Literally, there's a few different project management like methodologies. One of them is called waterfall. Waterfall is similar to an algorithm, step by step. We do this first, we do this second, we do this third. What agile allows for you to do is make it a bit more complex, right? So in agile, it says if we can do part one first, but then we can do part eight simultaneously, then let's do both. If we can do part one, part three, and part eight, if that's the best sequence, then let's do that. If we can work on part one and also work on part eight, then let's work on them both. It doesn't have to be the same team, but the processes can happen the same way. And a real world example of this is a team developing a new app releases a small working version every 2 weeks. They gather feedback and then they make improvements every cycle. Now, remember, they're consistently releasing new versions, which means that we may or may not have an idea of a final version, but what we're consistently doing is working and listening to the people and figuring out the glitches and figuring out the vulnerabilities and just massaging the process to a point where we get the best end goal. That's what agile is. It's the process. We can do different parts of it. They call them sprints in agile. And we can do this sprint, this sprint, this sprint. Some of these sprints might happen at the same time. Ultimately, the end goal, or something called the MVP, the most, what is it, valuable product, the most vulnerable, whatever. Hit the comments, but you want to get to an MVP. So a product that you can actually deliver to a group of people. They can let you know how they feel about it, and then you can move on with consistent improvement and advancement. Number three, HTTP/HTTPS. Now, they are almost the same thing, almost. HTTPS is a bit better than HTTP. They have their different uses. Let me explain. So those letters are hypertext transfer protocol. You'll hear protocols a lot in networking. So it is a foundation for data communication on the web. The S in HTTPS stands for secure. So it's more secure, it's better security. That's why I said it's quote unquote better, meaning data is encrypted amongst travel. All right, so a real world example is when you go on a web page and then it has that little lock icon on there. It's an indicator to let you know that this website uses HTTPS. Or if you look inside of a URL, you can see it actually. So it's just an indicator. You're using HTTPS. HTTP and HTTPS both have their different uses. But if you see the S, you know that that connection is secure. Machine learning, big buzzword. Machine learning is the AI thing, the thing that everybody thinks is going to take over all of the jobs. So, definition of machine learning is it's a subfield of AI that gives computers the ability to learn without being explicitly programmed. So, a real world example is nobody's sitting at Netflix and trying to show, like the best thumbnail for the recommended viewing history or the recommended movies that you should watch. Nobody's sitting there doing that. It's programmed inside of a computer to say, hey, try this, try that. If they like this movie, then take a clip from a different movie that may have a similar plot or it's an action or similar category. And once you take that thumbnail, insert it into this space so that the person can be enthusiastic about watching this movie. Literally, what the computer is doing is taking clues of other things that you've done or other film that you've watched, and it's using all of those clues to come up with a something that's attractive to you. And this is only me explaining Netflix's version of machine learning. A lot of them exist. There are different models, and we can get deeper into it. If you want to get deeper, head down in the comments, let me know. But that's machine learning in a nutshell. A bug. A bug. Like you always tell people don't be a bug. When bugs became a part of computing terminology, it was because the computers used to have knob and tube, and they used to have these little suction devices, and bugs used to get in them, and bugs used to mess up the suction. And from them doing that, they were called bugs, and blah, blah, blah. It's a whole story. But nevertheless, the definition of a bug is an error or a flaw in software that causes unexpected behavior. So basically, I press a button and I want this button to give me a certain outcome, but when it don't produce the outcome, it's called a bug. A real world example, again, a button on a website that doesn't work when you click it is a bug that needs to be fixed. Now, bugs can be anywhere without technology, throughout software, and even bugs can create vulnerabilities. So you have this term called debugging, and debugging is when developers sit down, they figure out what the bugs are, they figure out what their vulnerabilities are, they debug it, and once they debug it and push out a new software, that new software is called a patch. We'll get to patches later down the road. All right, so SQL, your boy's in the way. Let me move me. There we go. SQL, structured query language. So SQL is a standard language used for managing, manipulating relational databases. So it's, again, that's what it is. If you like a data person, like a data engineer, a database administrator or something like that, you will need to learn SQL. Everybody doesn't need to necessarily learn it. A lot of like the simple code, and if you see it, it's super simple. A lot of that can easily be, you can hit Google and, hey, I need this SQL script for blah, blah, blah. And they'll literally break it down for you. Even if I said the terminology wrong, Google will correct you and they'll give you the correct way of going about gathering the information that you need. So a data analyst uses SQL query to find all customers who live in a specific area. This goes back to the video where I spoke about databases. It also goes back to like the machine learning thing. Most things that are on the computer are, well, we call it all data, but when it sits inside of a database, you have to be able to search that database, and you got to be able to search it efficiently. And a way of searching it efficiently is using SQL. Here we go. All right, next, a VPN. I said last video that VPN and Agile, I had the definitions all crunkled up and mixed up, but now we're going to talk about VPNs. So a VPN is a virtual private network. What a VPN does is it's a service that encrypts the internet traffic and routes it through a secure server, masking your IP address and protecting your online privacy. A real world example is using a VPN on a public Wi-Fi to secure access to your company's network or to browse the website privately. So a VPN, you hear these things called VPN tunnels, and basically organizations pay networking companies, Cisco for instance, to utilize VPNs. So Cisco's VPN is called like Cisco something client. I forgot the name of it, but nevertheless, it basically creates a tunnel within networks, which allow for you to have a straight shot to the information that you need. So an example is if you're at home on your computer and you have a VPN tunnel, you have to go through the VPN tunnel in order to get the information that sits on your organization's server. The easiest way to think about the tunnel is to think about a hallway, right? So, and this is how I